Hi everybody, welcome to day 2 of variation. We're going to be doing application problems today, so how are they useful? The first one, not really an application, a little fun fact about Bill and I problem, but it's going to just recap what the first lesson on variation was, so here we go. Fun fact about Bill and I, the science guy. Loved him growing up. Bill's first job began in Seattle at blank, where he developed a hydraulic pressure resonance suppressor. Sounds fancy. Not sure what that does. Answer the following to find out. So, if y varies inversely as x and y equals 8 when x equals 5, find x when y equals 2. It's like a two-part problem here because we have two pieces of information. We have a given x and y combination, and then we have a new combination of x and y where we don't know the x. So let's start with the known information. First of all, it's inverse variation. So if we take this piece of information that we know already, one that it's inverse variation, so y equals a constant divided by the x quantity, we can set it up using this pair that we know. Y is 8 when x is 5. So we'll just substitute them in. Y is 8 while x is 5. The constant we don't know. We're going to find that constant so that we can figure out the next part. So then when we're dealing with this sort of problem, there's like two different ways you can deal with it. You can, since this is dividing by 5, you can multiply the 5 out. I think for a lot of people, it helps to think about this as 8 over 1, which is still 8. That way you can cross-multiply. Cross-multiplying something that a lot of people tend to be really familiar with and comfortable with from middle school. So, whatever you like. So, crisscross applesauce on that. And you do the 8 times the 5, which is 40. And then it's set equal to the other crisscross, which is 1 times k, or just k. And that was kind of the whole point right there, to figure out the constant of variation. Now, we haven't figured out the answer yet, because that's how the change is working on our variation. Now we need to find a new x given a y value. So that's going to be like a little part 2 of this problem, where now we can take this known information with our equation, 40 being the constant. That's the equation now of variation. And so we can use this, find x when y equals 2. If y is 2, we plug it in. 40 we know is the constant. It's always that. It's a constant. Find x. We don't know x. So again, this one, you could, don't multiply by 40. 40 is on top. If you multiply 40 by 40, you're just going to get a big number. It won't cancel out. So I think, again, a good way to do this problem is to do 2 over 1 and then crisscross applesauce. Then you get this new equation, the 2 times x crisscrosses, and then the 1 times 40 crisscrosses. Now this isn't done the way that the previous problem was, because x is not solved by itself, so just divide out the 2, and 40 divided by 2 is 20. And so this is our final answer. We found the x when y is 2. So the answer to this little fun fact about Bill Nye is that his first job in Seattle was at Boeing, and that's where he developed that resonance suppressor. Research that, figure out what that does. Alright, so that was the gist of inverse variation from yesterday's lesson, and then there was direct variation built in. We're going to focus on inverse for our applications. So here's some application problems now. Here's the wording to look out for. It's going to help a lot when doing these problems. It's going to tell you that the y is inversely proportional, which means inversely varies, or it'll actually say inversely varies, but it's going to say the y is inversely proportional to x, or y varies inversely with x. So let's read through this first one. Example 2. The number of hours it takes to organize the pages for copies of a book varies inversely as the number of people on the job. I'm going to stop right there. So this first part, we've got the number of hours it takes. That's one of the things that we're dealing with. Organizing pages of the book varies inversely. There's our little middle part of the statement. Varies inversely as what? As the number of people on the job. So we've got our x and our y. Remember back up here, y varies inversely with x, or y is inversely proportional to x. So the number of hours is the y, and the number of people is going to be the x that we deal with. All right, so now we're given some numbers. Suppose that a crew of 4 people take a total of 12 hours to do the job. We're going to figure out how long it'll take 10 people to do the job. First, we have to find the constant. It's basically this exact same thing that we did up here, just with some words, some context, right? Because here, before we could answer this, we had to figure out the constant with 2 given. So we're going to find the constant with these 2 given first. All right, let's get to it. So setting it up, we know it's inverse variation. So we know it's going to be y equals k over x. We know certain pieces of information. 4 people, and that's going to be the x, take 12 hours, and hours was the y value. So then we just plug in our information. Y is 12. We don't know the constant, but we do know the x is 4 people. And then we solve. So different ways to do this. I'm going to put 12 over 1, and then crisscross applesauce, multiply that out. So you get the 12 times the 4, which is 48. And that's equal to 1 times k, which is just k. So there's our constant of variation. So that's what we need to be able to answer this question here. Ultimately, how long is it going to take 10 people to do the job? So here's the equation. Y equals the constant divided by the x. How long would it take 10 people? Well, 10 people is the x. It's important to make sure you know where to plug in that number. So y, which we're finding, that's the time, is equal to the constant of variation divided by the x, the number of people. And if you divide this out and get a decimal, and decimal's okay here, it's about 4.8 hours. We were looking for time, and we can have parts of an hour, so a little bit less than 5 hours for 10 people to do the job. It's reasonable if you think about it. 4 people took 12 hours, so more people, 10 people, took less time. That's what inverse variation is. It's kind of like this opposite relationship. All right, moving forward. How many people will it take to do the hour or do the job in 3 hours? So same kind of question. We're still going to use our setup of inverse variation, this, but now we're given the hours, which is the y variable. So we're going to put 3 equals instead of y equals. The constant is constant, and we're going to find the x. All right, so I'm going to put 3 over 1 and then cross multiply to solve. So 3 times x equals, and you crisscross 1 times 48. And when you divide the 3 out to solve for x, you get 16. All right, and so that is the number of people needed. Wow, that's a crazy looking people. Anyway, that's the number of people it's going to take to do the job in 3 hours. No decimals here. Decimals would be a little bit awkward because you don't want to, chop up a person. A little psychotic. So that's it. Okay, a couple more problems to practice out the applications. Let's get to it. The time it takes you to get to campus varies inversely as your driving speed. So we know we're dealing with inverse variation. We know 2 things. That we're dealing with the time. So it's going to be y. Y varies with x. So the time varies with driving speed. All right, we average 20 miles per hour in bad traffic. It takes 1.5 hours to get to campus. So from that information, 20 miles an hour, that's going to be the speed. That's an x. The 1.5 hours to get to campus, that's the time. That's the y. We're going to stop right there because the second part of the question, we're going to need to find a new time given a new driving speed. So this is like a 2-part little question here. So the first part of it I'm going to do on the left. This is where we have to figure out our constant given known information. Well, here's what we know. Inverse variation. Y equals k over x. We know the y is 1.5 hours, when the x was 20 miles per hour. All right, so you start with those, and then you solve for the constant. Just like we do with anything else, you can either multiply the 20 out from the denominator, or you can set this over 1, and then you can cross multiply to be able to get your answer, but you'll end up with the constant being 30, as long as you do that correctly. Alright, so the whole point of that is so that now we can go over and use our constant to find a new piece of information. Because now we've got y equals, we have a complete equation where the constant is 30. But now we're trying to find a new time, how long is it going to take, that's a y, to average 50 miles per hour. So now we've got this average miles per hour, which is going to be the x, so that's our driving speed. So this x is now going to get used over here in this problem, where it's 50 miles an hour is the x, we know what the constant is, and we're finding that new time, that y value. So here, when you divide 30 by 50, you do get a decimal, but that's okay, we're looking for time. So the answer here would be 0.6, and we were looking for how long it would take, so that is hours, because we're dealing with like per hour. Right, so it makes sense if you think about it. 20 miles per hour, it's going to take you a long time, an hour and a half. You go faster, 50 miles per hour, it's only going to take a little less than an hour, 0.6 of an hour. All right, let's do one more. Example 4. In a construction project, the number of workers needed varies inversely to the days on the job. All right, so we know it's inverse variation, and we also know our y and our x. So in this project, the number of workers, that's y, varies with the days on the job. So how many workers compared to how long the job's going to take, basically. One job site has 5 workers, must be completed in 24 days. Right? Then suddenly the company decides to complete it faster, so they're going to hire more people. How many workers are needed to complete it in 15 days? So here's another little 2-part question here. Let's start with the first piece of information that we have. We know that there are going to be 5 workers, and workers is the y. And we know that has to be completed in 24 days. So that's going to be the x, the number of days. Scribble over that. Okay, so again, back to what we know. Y equals k over x. It's inverse variation. The number of workers, 5 workers, when it needs to be done in 24 days. We do not know the constant, but we're about to find it. So when you multiply that out, you can do 5 over 1 and then cross multiply, but 5 times 24 is going to give us a constant of 120. Okay. Then we take that over to part 2 of the problem, because now we know the equation. The constant is 120, and we can use this equation to figure out now, well, how many workers are needed to complete the construction project in 15 days? So that is the x. Remember that x is the days. You got to know where to plug that in. So now we go to 15 days is the x. The constant's still 120, and we're going to find the number of workers, y. So now all we need to do is that division. That's just straight up 120 over 15 divided by 15, and we get 8. 8. What are we dealing with here? How many workers? So 8 workers. All right, and there it is. Voila, we've got it. So more workers needed, right? There was originally 5 workers, 24 days. So 8 workers, 15 days. Inverse variation. Okay, and now try out these problems on your assignment. Your assignment does also cover some recap of yesterday's direct versus inverse variation.